Myself, Dr. Amarnath Shetty, professor in the AJIT Civil Department, Mangalore. Now, I'll go for the important questions of this one. First module. First one, point to be considered for protected water supply scheme. Yeah, this is very important. The following factors should be kept in view in water supply for the particular place. Okay, the source. First one is the source. Source should be selected which may be sufficiently provide the water in all the seasons. The source may be well, streams, natural lakes, a deep pond, in a reservoir, river, or mineral river, etc. Okay. Second one, quantity of water. It is estimated by considering need of present population and future population growth during the design period. Also, some quantity of the water will be required for fighting, okay, public places, public convenience, firefighting, okay, street washing, and horticulture purpose. In addition, some of the water usually wasted by consumer. Thus, the total quantity way of water may be estimated for particular locality. Considered all above factor. The quantity of the water, very important, quantity of the water depend upon the for firefighting, public convenience, street washing and horticulture, etc. Okay, this is very important. Okay, check calculation. Another is the check calculation. Check calculation is check calculation. After above the calculation is completed, designing should be again confirm whether the source of water is provided, the required amount of water, especially summer season of the driest year. Okay, this is the check calculation. Okay, next one, distance and the difference in elevation. Okay, the designer should be see distance and difference in elevation in the town with respect to the source of water. As far as possible, water should be under enough pressure in a service pipe so that it may reach us up to 10 to 15 meter. This is the distance and difference in elevation. Okay. Now, impounding reservoir may not be provided if the provision at the higher elevation is not economical. This is also important. And quality of the water, very important. After this, quality of water should be tested. Treatment unit should be installed according to degree of pollution in the source. Okay, quality of the water, very important. We have to test the water after the treatment also. Okay, treatment unit installed, degree of this. Methods of purification. Methods of purification of the drinking purpose may be divided into 5 parts. Yeah, methods of purification. This is also important. Screening. In this fine and coarse particle rack papers are separated through the fine and coarse screen. Okay, plain sedimentation, in which sedimentation is of a set level solid in a large tank is affected. Coagulation and chemical precipitation. This is adapted when the much turbidity, the alum solution generally mixed in the water for a purification is formed, which later separated. Okay, filtration, in which water is passed through the layer of stone and sand. Okay, stone and filtration purpose. Okay, disinfection, it is removal of pathogenic bacteria or destroy a pathogenic bacteria. Next one, service reservoir. This is an important part. Service reservoir. The water may be stored in a higher elevation of the town is called a service reservoir. From this reservoir, the water may be supplied in a hour or a peak demand. Okay, this is stored at the higher elevation of the town. It directly supplied. And distribution system. This is also very important. Distribution system. The water from the service reservoir served consumer through the network main, sub-main, lateral main is the distribution network. Okay, this is the first important question. First part, this is how to protect the water, in the need of protected water supply. Okay, first part. Second, we go for the demand of water. Very important, types of demand. Okay, domestic water demand, industrial and commercial water demand, fire for public use, fire demand, okay, and water required for in loss of water theft, okay, consumption losses in water and theft. Okay, first one, domestic water demand, industrial and commercial water demand, demand for public use, fire demand, water consumption losses, compensating losses in waste and theft. Okay, how to compensate a loss of waste. First we go for the domestic. How the domestic demand done? Drinking 5 liter, cooking 5 liter, bathing 55 liter, washing clothes to 20 liter per day, washing utilities 10 liter, washing, cleaning and machinery. Total there is a per day, per liter, per head per day is 135 liter. This is the domestic water demand. Okay, 135 liter per day. We should one person municipality will give 135 liter. Okay, 135 liter. Then we go for the industrial and commercial water demand. That is depend upon the factories, whether the bathroom is there, is the factory if it is not there. If the bathroom is there, 45 liter is provided. Where no bathroom, 30 liter per head per day. Hospital, number of bed more than 100 bed, it is 340 liter. The number of bed less than 100, 450. Nurse house 135 liter, hostel 135 liter per head per day, all per head per day. Hotels, this per bed 180 liter per head per. Restaurant per suite 70 liter per head per day. Office 45 liter per head per day. Cinema, auditorium and theatre 15 liter per head per day. School, day school is 45 liter per head per day. Residential school 135 liter per head per day. This is about the industrial and commercial. How much water required per day per this one. Okay, this we can see this. Okay, all this we can see. Okay, then we go for the demand of the public. Public consumption is the demand. How much in the quantity of water in public park, gardening, washing, sprinkling of road, fountain, etc. Okay. Now we go for the public park. Water consumption is 1.4 liter per meter square per day. Road watering 1.2, 1.5 liter per meter square. Sewer cleaning 4 liter per head per day. Okay, this is sewer cleaning. This is very important. Now we go for the fire demand. This is very important. Fire demand. How much water will keep for supplying the storage in a reserve, in a service reservoir or in a tank, or in a supply system? How much water we have to store for fire? There are different types. National Board of Fire under a Richter formula. Q is equal to 4640 square root of P 1 minus 0.01 P. There the Q is obtained in liter per minute. P is the population in 1000. Okay, P is the population. Q is the liter per minute. Then Freeman formula. Q is equal to 1135. This one P by 10 plus 10. Q is the amount of water liquid in liter per minute. P is the population in 1000. Quicklin formula. Q is equal to 3182 square root of P. At the demand rate maintained at the hydraulic 1 to 1.5 kilometer square last for 3 hours, where Q is the amount of water liquid in liter per minute, P is the population in 1000. Okay. Then Wste formula. Q is equal to 5663 square root of P. All above formula, the first drawback. This not related to area served. This formula is equal to the result of industrial, non-industrial area. Though this possibility of occurrence of fire with the given duration of the same industrial compared to the non-industrial area. Now we go for the very important nowadays, water required for compensating loss in waste and theft. Okay, it is very important, especially like Bangalore, Bombay, all corporate areas, metropolitan cities. Okay, 30 to 36% water is lost via losses, leakage, faulty connection, faulty fitting, running tap, damage meter, theft, unaccountable connection. Okay, it includes a water loss, leakage of the bad plumbing and or a damaged meter, stolen water due to unauthorized water connection or other losses and water wastes. Okay, these losses may be taken account while estimating the total requirement. These losses can be reduced carefully maintenance of universal metering. Even it is the best managed work amount of 15% of the total consumption. Okay. Now we go for the next fourth question, fourth important part. Okay. Design factor and factor affecting the design factor, very important. Water supply scheme involve construction, installation, commissioning, or a several large structure, and few underground. There is not easy to replace or repair or expand short notice, since the water supply scheme usually meant for term looking for a futuristic rate of growth. It must be set inclusively for expansion. The unit lead must be larger for current requirement and large hence should be able to resolve future demand. Also, it must be considered optimum life component structure for the water supply scheme. The design is 30 years. It meant for 30 years. Design period, storage dam is period is 50 years. Okay. Overhead tank 15 years. Distribution system 30 years. We have to design. Water treatment 15 years. Okay. Design period, very important. We have to useful what are the factors affecting design period. Useful life of the component structure. Okay, first one, flexible in expansion, how easy or tough to expand future data. Financial ability, less money then design period is small, you cannot invest more construction. Also interest is less, high design period. Okay, expected development, change of population and influence the commercial industrial growth. The population growth is less, high design. Okay, this design period very important. We have to keep in mind future that we have, if you design the storage dam, we have to keep in mind 50 years, future 50 years. Okay, overhead tank future 15 years. Okay, distribution system we also think about future 30 years. Okay, the water treatment unit future 15 years. Okay, very important. And however, we have to keep 30 years for this 1 year design period, subject of this factor. This factor is very important. We are not having the fund by the government. Okay, government fund is not there to construct that. We have to keep the place for that. Okay, flexibility for expansion. Okay, expected development, change in the population, influence of the commercial. Okay, we have to keep all this in mind for the design period. This is very important factors we have to keep in mind. Okay.